Hello students, once more into the wonderful problems of calculus. Here we are looking at another rate problem, and in this case we're given just a single rate, and we're dealing with traffic flow this time. We're not given any initial information, we don't have a table, so we're not going to deal with any RAM stuff. We will likely have to deal with both a derivative and an antiderivative of this function. This is calculator active. We should expect that we should not be doing those by hand, although in this case you would be able to, but because this is calculator active, you do not have to do that. And we're probably going to have to talk about the meaning of some of these things. Alright, looking at part A. So we are looking for the number of cars that pass through this intersection. So for that I'm looking for some kind of accumulation, so that's an integral. Because we're looking over this entire 30-minute period, that's going to be going from 0 to 30. And we're looking for our function f of t dt. Again, this is calculator active. I want to note a couple of really important things. The first is I didn't write this on my paper because I'm more likely to make a transcription error than if I just use its name, big F of t. The second piece of this is that because this is calculator active, we probably should be putting this function for y1. We're probably going to have to use it a couple different times over the course of this problem. So as we are looking at this, this is probably going to be almost all that we need for this. When I throw this on a calculator and we're asked to round to the nearest whole number, I get the number 2474, and the units here would be cars. Looking at part B. Is the traffic flow increasing or decreasing at 7? So we're given an equation for flow. If we want to know if this is increasing or decreasing, this is really talking about f prime. And if we're talking about f prime of a specific value, basically, again, this is a calculator problem. Your goal here is to use nderiv, and hopefully you've put this function for y1, and setting x equal to 7, and basically being done here. When I do that, I get a value of negative 1.872-ish, and if I've got a negative value here, that means that my function f of t is going to be decreasing there. So since f prime of 7 is less than 0, f is decreasing at t equals 7. A couple things I want you to be aware of. I did not use the word it at all here. I'm being very cautious and using the names of the functions that I'm given every time I see them. For part C, average value. Okay, that's pretty clear to me what I'm looking for there. I need an average value thing of the traffic flow. Cool, that's what the equation we have. And then interval 10 to 15 minutes. So this is not looking for my entire thing. So we'd be looking from 10 to 15. And that's going to be 15 minus 10. We're dividing by the width of that interval of our original function, f of t dt. Again, this is a calculator problem. The goal here is to make sure that we are showing the steps. We do not have to show or say, I did this on the calculator. That is the expectation. And then giving some kind of an answer. In this case, it's going to be 81.899 cars per minute. Love it. All right, what is the average rate of change? Ooh, this is fun. So we had an average value in the previous problem, and here we're asking for an average rate of change over the same interval. I actually really like that both of these are being asked for together, because I think that makes it a little bit clearer which one is which. So average rate of change, we know that's the slope between endpoints. That would be f of 15 minus f of 10 divided by 15 minus 10. And when we do that, again, this is calculator active, you do not need to show the work for this. You probably need that difference quotient depending on how points come out, or you might not. When I do this, I'm going to truncate and get 1.517. You could also round up and get 1.518. And I'm just going to think about the units for a minute. So up top, that was cars per minute. And on the bottom, that's per minute again. So we could write this as cars per minute, or we could write this as cars per minute squared. Either answer would be okay. Looking at this as a whole, we were given a function that is a rate. We did some integration, we did some differentiation, and then we had to find the average value and the average rate of change based on this function. This was calculator active, so the vast majority of the work that we did would have been on the calculator. This also is a great example of a problem that you can do without a calculator, but instead of this being a 5-minute total problem in terms of the math here, you might end up spending a huge amount of time just trying to make sense of this. And finally, let's look at some of these points here. For the first one, we got 1 point just for the limits, the 0 and the 30. 1 point for the integrand, putting f of t on the inside. 1 point for the answer. For the second one, only 1 point overall for the answer with the reason. So identifying the value of f prime, which we did, and saying since it's less than 0, which we did, the flow is decreasing at t equals 7. I love it. Number C rather, the limits of integration, 10 to 15, the integrand, f of t on the inside again, and then the answer, basically knowing that you got to multiply by 1/5. And then finally, you don't get a point for the difference quotient, you get 1 point overall. And then we get a point for making sure you have the correct units in C and D. If you have one pair of incorrect units, you don't get any points for that.